Good afternoon and welcome to the session 4 from the chapter of waves. The topic is the factors affecting the speed of sound in a gaseous medium. And based on this topic, I have written here three important points which will help us to understand the effect of temperature, effect of pressure, and the effect of humidity on the velocity of sound in a gaseous medium. So the first point here is the effect of temperature on the velocity of sound in a gaseous medium. Now the velocity of a sound in a gaseous medium is given by this formula, that is under root gamma RT by M, where M is the molar mass, T is the absolute temperature, R is the universal gas constant, and gamma is equal to Cp upon Cv, where Cp is the specific heat capacity at constant pressure and Cv is the specific heat capacity at constant volume. So for a particular gaseous medium, gamma, R and M will be a constant. So the velocity of sound in a gaseous medium is directly proportional to under root T. Or we can write this relation as V1 upon V2 is equal to under root T1 upon under root T2, and this can be written as under root T1 upon T2. So if I know the velocity of sound at a particular temperature, say T1, then I can calculate the velocity of sound in the same gaseous medium at a particular temperature, say T2, by using this expression. Now the second point here is the effect of pressure on velocity. Now in this formula, if the temperature is kept constant, then we can say that the velocity of sound will remain constant, or we can say that there is no effect of pressure on the velocity of the sound if the temperature is constant. The third point here is the effect of humidity. Now this is the formula for the velocity of the sound in any gaseous medium. So this formula can further be written as that gamma RT by M, under root gamma RT by M, that this is equal to under root gamma PV by M. This can further be written as under root gamma P upon D here. And here D is what? This is the density, P is the pressure, and gamma is equal to Cp upon Cv. So from here, from this relation, we can see that the velocity of the sound will increase if the density decreases. Now, when the humidity increases, the density decreases. So, we can simply say that the velocity of the sound will increase when the humidity is increasing, because when the humidity increases, the density decreases, and when the density will decrease, the velocity will increase. So, when the humidity increases, the velocity of the sound will increase, and when the humidity decreases, then the velocity of sound will decrease. So thank you very much for joining this session. In the next session, I will be coming up with one numerical problem based on the topic of the factors affecting the speed of sound in a gaseous medium. So till then, have a nice day. Bye.